Alright, so this is your recording for lesson 12-2. We're going to be talking about point-slope form today. So yesterday you talked about slope-intercept form, which was y equals mx plus b. So we focused in on how from the equation, from a graph, from a table, we could identify the slope and identify the y-intercept in order to be able to graph the line, write the equation of the line, all of those good things. So point-slope form is a much more useful form when you are trying to write the equation yourself. When you are trying to graph the equation, slope-intercept form is very convenient because you can look at it very easily and see what the slope is and what the y-intercept is. But point-slope form is a little more useful because you don't always know the y-intercept. The y-intercept is just one little tiny point on a line. Sometimes you might have other points and the y-intercept might not be there, especially when you're looking at a table rather than a graph. So that's why we need to learn alternate forms, and today we're going to learn point-slope form. So point-slope form, you can see it down here, y minus y1 equals m times the quantity x minus x1. Now, it says very clearly here, m is the slope of the line, x1 comma y1 is a point on the line. So this is an ordered pair, and you can see that these values show up here and here. So this y and this x are the actual variables, the ones that stay y and x. The x1, y1 are the ones that we're going to plug in. So this formula, it tells you where it came from taking the slope formula, multiplying both sides by x minus x1. So that's all. That's where it came from. So example A is showing you that here when we know the slope and we know a point that it passes through, that we could then use this form. If we just knew these two things, we wouldn't be able to write in slope-intercept without actually graphing it first because we don't know the y-intercept, so we wouldn't know the b. So we can write that. Sorry, this thing, when I try to move, it goes really fast there. All right. So here I have taken this point, 2, 5, that's x1, y1, and 1/2 is m, and then we just plug them into the formula. So y minus 5 equals m, which is 1/2, times x minus 2. So when you are graphing from point-slope form, all you do is plot the point that they gave you. So in this case, they plotted 2, 5, and then use the slope to find another point, because remember, the slope, m, is rise over run. So that means from this point, I can rise 1 and run 2. Make another dot. Rise 1, run 2, make another dot. So on and so forth. And we go the other way as well. When you are graphing using slope, you need to continue until you get like off the page, basically. So you keep making these dots until you go off the page. Remember that 1 over 2 gives you 1/2, but negative 1 over negative 2 also gives you 1/2. So you can see here, if I go down 1, left 2, down 1, left 2, I get the additional points on the line there. So we wrote the equation, and then we graphed the line using our new form, point-slope. So now it asks you to try this yourself. Oh my gosh, I'm so sorry. It does not want to stay exactly where I want it to stay. Ooh, there we go, close enough. Okay, so in try these A, find the equation of the line given a point and the slope. Then in C and D, determine the slope and a point on the line for each equation. So what I'm going to do is I'm going to do part A and part C here, and then we're going to pause the recording and let you try B and D just to make sure you understand those. So here, I'm going to use my point slope form. I'm going to write it again over here. I know you can still see it on your paper, but since I've scrolled past it, I'll put it right here. So for A, this means that my x1 is -2, my y1 is 7. My m, of course, is 2/3. So I'm going to write y minus y1, which is 7, equals m, which is 2/3, parenthesis, x minus x1. Remember, when you write minus -2, that becomes a plus. Now, if you don't see the plus immediately, you can certainly write minus -2 in your first step, but in your simplified answer, it does need to be a plus. So this would be our equation then for try these A, part A. So then let's look at C, where it's kind of the opposite of that. Here we have the equation, and we want to identify the slope and the point. So the slope, of course, should be over here in front of the parentheses. So we will say that m is 3/8 in this case. Remember that this was subtraction in both of these. So x minus x1, so that means the x-coordinate of my point is 3, and this is y minus y1. Now, this is a plus here, which means that my y1 had to be negatives, and the minus negative gave me the plus. So I know that the value is 4. I know that it has to be negative in order to get that plus. So that gives me my y-coordinate is -4. So whenever you see a plus here, you can still just look at the number, but you'll just change the sign to a minus. So the minus is what you see is positive. So really what ends up happening is that when you look at it with the y and the x, the opposite of whatever sign you see there is the sign that goes in your ordered pair. So here we saw a -3, and we write a +3 here. In this, we saw a +4, and I write -4. All right, these are pretty quick examples, so just pause the recording for maybe 2 minutes to give you a chance to work out B and D on your own. All right, so let's go ahead and check your answers here. For this one, with my slope and my given point, this is x1, this is y1. So you should have done y minus -1, minus negatives become pluses, equals the slope, which is -5/4, parenthesis, x, minus, and then x1, which is 6. So this should have been your equation there. Down here, we're just identifying the slope would be this guy, so -5/2. The point, remember we changed the signs. This is a plus, so my point will have a minus. This is a minus, so my point will have a plus, which is -3/6. All right. So let's continue. The town of San Simons charges its residents for trash pickup and water usage on the same bill. Each month, the city charges a flat fee for trash pickup and a fee of 25 cents per gallon for the water used. In January, one resident used 44 gallons of water and received a bill for $16. It says if X is the number of gallons of water used during a month and Y represents the bill in dollars, write a point X1, Y1. So that means they gave us the values that correspond here, and that would be in the last sentence. One resident used 44 gallons of water and received a bill for $16. So X is the number of gallons, so my X1 would be 44. My Y1 would be the amount of money, which would be 16. So 44, 16 would be my X1, Y1. 2, what does 25 cents per gallon represent? The per should be the key here. It represents the slope or the rate of change. So it represents the slope. Because for each additional gallon, $0.25 more is charged. Number 3, use point slope form to write the equation that represents the bill cost, Y, in terms of the number of gallons of water, X, used in a month. So as I look here, I've got my X1, Y1, remember that's up here, X1, Y1. I've got my M is the 25 cents. So Y minus Y1, which is 16, equals M, which is 0.25, times X minus X1, which was 44. And so there's my equation. Number 4, write the equation from item 3 in slope-intercept form. So this is important if we need to know the y-intercept, which happens a lot in real-life situations. So all I'm going to do is I'm going to rewrite the point slope form. And to get it in slope-intercept form, that means I need to first distribute. So out here, you want to write out the steps from changing from point slope to slope-intercept. So step 1 is to distribute. And we should say distribute the slope. So I do that. So 0.25 times x is 0.25x. Then don't forget to distribute to the second term as well. So I need to distribute the 0.25 to the negative 44. So 0.25 times 44, and it's going to be negative since this was a minus, gives me 11, so minus 11. And then the left side I still have y minus 16. So now the next step after you distribute the slope is move the y1 value to get y alone. So in this case, that means I need to add 16 to both sides here to get y alone. That'll give me y equals 0.25x plus 5. It asks what the y-intercept represents. Remember that x is 0 at a y-intercept. And here it says that x represents the number of gallons of water used. So the y-intercept represents when 0 gallons are used, the charge is $5. You could also interpret it even a little bit more and say that it represents the flat fee water charge, because that of course means the same thing here. All right, so looking at number 5, determine the slope of the line given the point 86, 125 and the slope, or determine the equation of the line. All right, so I'd like you to do this one on your own. So go ahead, just take a minute, determine the equation of the line going through this point with the slope negative 18. So shouldn't take much more than a minute. In fact, instead of pausing it, I'll just wait here for a second while you do that. All right, since this is your x1, y1, and you've already got your m, you should have said y minus 125 equals slope, which is negative 18, times x minus 86. So that should have been your equation there in number 5. All right, so now we're going to look at number 6, and number 6 is actually very similar to the situation we just did here in numbers 1 through 3. So it gives you a situation, it tells you kind of how much she makes, and it gives you kind of an ordered pair. So just like we had to identify the x1, y1 from the situation with the water and the price, you need to do the same thing here in number 6. So go through, follow the same steps that we did in 1, 2, and 3 to go ahead and write an equation representing Violet's situation here. So go ahead and pause the recording. I would say this should take about 3 to 5 minutes to go ahead and do this. So pause it, and then we'll unpause it here once you've had enough time to try it. Okay, so if you're following the steps in 1 through 3, the first thing we had to do was identify the x1, y1. So that would be right here. If she sells 8 sets, she makes $2.25. So that means that this is my x1, y1 point, 2.25. Then I know that the slope is going to be the rate of change, which is her profit. So I know that m is 0.75. So then, write an equation representing her weekly possible earnings. So y minus y1 equals m times x minus x1. And so you should have written this in point slope form. Now, I did say 1 through 3, so hopefully that's as far as you went, but if you did go ahead and also make it slope-intercept form, that's fine because it didn't specify what form it wanted you to write it in. I am going to go ahead and just illustrate one more time how to change from point slope to slope intercept. So this is a perfectly fine answer for number 6, but I'm just going to illustrate how to put it in slope intercept form again. So our steps that we wrote out here in the margin, distribute the slope first. So that'll give me 0.75x here. And then I also need to multiply the 0.75 times my negative 8. So that's going to give me a minus 6. Then over here I've got y minus 2.25. So then if I want to get y alone, I add 2.25 to both sides. Now remember the 6 is negative. So I'm going to get 0.75x, negative 6 plus 2.25 is going to give me negative 3.75. So minus 3.75. This would be slope-intercept form. Again, we don't need it in slope-intercept form. I just wanted to give you one more example of that. All right. So moving on to the next page. Number 7. Jamila and Ryan were asked to write the equation of the line through the points 6, 4, and 3, 5. Both Jamila and Ryan determined that the slope was negative 1/3. Jamila wrote the equation of the line as y minus 4 equals negative 1/3 times x minus 6. Ryan wrote the equation of the line as y minus 5 equals negative 1/3 x minus 3. So, rewrite each student's equation in slope-intercept form and compare the results. Okay, so slope-intercept form, we will write that, so that's what we just practiced in the last one. So I'm going to take Jamila's first, so y minus 4 equals negative 1/3 times x minus 6. And I'm going to deal with that one first. So distribute our slope. So that gives us negative 1/3 x. A negative times a negative is a positive. 6 over 3 does come out evenly. That gives me 2. And then I've got the y minus 4 over here. So add 4 to both sides then to get y alone, and y equals negative 1/3 x plus 6 is the slope-intercept form of Jamila's equation. So now I need to look at Ryan's equation. So maybe use green here. So Ryan's was y minus 5 equals negative 1/3 x minus 3. So same idea. I need to distribute my slope first. So I know this is going to stay y minus 5 for now. Gives me negative 1/3 x. Again, a negative times a negative is a positive. That gives me 3 over 3, which is 1. So after I distribute the slope, I move the y1 to the other side to get y alone, which is going to give me negative 1/3 x plus 6. So compare the results. Obviously, they're the same. So whose equation was correct? We would say that both equations are correct. The reason that their answers were different to begin with is because they used two different points, because we knew that 6, 4 and 3, 5 were both points on the line. So when Jamila wrote hers, she used this first point as her x1, y1. Ryan used this one as his x1, y1. So both equations are correct. They chose different points for their x1, y1. So that's why it looked different originally. Number 8. Find the equation in point-slope form of the line shown in the graph. All right, so in point-slope form, that means we can pick any point we want, and we can see how this is convenient because we can't see a y-intercept. So writing it in slope-intercept form is going to be a little difficult here. So I can pick any exact point that I want. So the first one that I see here is at 2, 2. So I'm going to go ahead and use that one. So I'm going to make 2, 2 my x1, y1. Now again, you could choose any other exact point you want. I see another one up here that we could have chosen. So the other thing I need in point slope form, remember, other than my x1, y1 is my slope, my m. So here's the formula again. So m, remember, I get by counting rise and run when I'm on a graph. So here's the other exact point that I see. So I'll draw my rise, run triangle and then count the values. So 1, 2, 3, 4, 5 is my rise. My run is 1. 5 over 1, rise over run, is 5. So that is my m. So I've got m, I've got x1, y1. That means that I am ready to plug it in. So I can do y minus 2, which is y1, equals m, which is 5, times x minus x1, which was also 2. Number 9 asks us to write that in slope-intercept form. So I'm going to recopy again so I don't mess up how the answer looks here. Distribute my slope. So 5x minus 10, y minus 2. Then add the y1 in this case. Y equals 5x minus 8. So, you can see here why I can't see the y-intercept. It would be all the way down at negative 8, which we can't see here. All right. Wrapping it up here. Number 10, explain the process you would use to write an equation of a line in point-slope form when given 2 points on the line. So, this is where you would say, find slope using y2 minus y1 over x2 minus x1, then pick one of the points to use as x1, y1. Plug slope and x1, y1 into y minus y1 equals m times x minus x1. So this is our entire procedure when you're given 2 points on the line. The reason why they have us answer these questions is because when you look back at your notes, these should be the steps. So it should be pretty easy to come back and look at this if you're like, oh, I'm given 2 points. How do I do that again? Here's our answers. 11, describe the similarities and differences between point slope and slope-intercept. So in both, slope is easy to identify as well as one ordered pair, because in slope-intercept form, you can identify the y-intercept as an ordered pair. So in point-slope form, it could be any point. And that would be the differences. I kind of ran out of room here writing it. But differences would be slope-intercept can see y-intercept, but not in point slope. Sorry, that's so squished. All right, that's the end of lesson 12-2. If there's time left, go ahead and start your homework.